Dr. Rutu Parekh did her MTech and PhD from Canada. She is also postdoctoral fellow at Center of Excellence in Nanoelectronics from IIT Bombay. She has industrial and research experience with eInfochip in Canada. She is currently working as a professor in DAICT Gandhinagar. She has published a number of research papers in international journal and international conference. In addition, she has been offering service as an editorial board member in various international journal and conferences. Now I would like to invite Dr. Prashant Shah, head of the EC department, for introduce about the workshop. Yes.
So good afternoon, one and all present here. So the workshop on building IoT system, basically this workshop aims to make you learn about how various parts of an IoT system are being integrated or are being coordinating with each other to fulfill their own functions. Okay, so basically if you see that now IoT founds application in each and every domain, whether it is a civil engineering, mechanical engineering, or you take electronics, electrical. So all the branches of engineering have now different applications of IoT. If I talk about the basic building block, then you start with the sensors, which is collecting the data. Then those sensors are sending the data, or you say that it is connected to the cloud platform. So sensing the data is one of the block. The second block can be the sharing the data over the cloud. Okay. And then data processing, and then finally the user interface. So these are, you can say that, 4 basic building blocks of any Internet of Things system. Okay. So this workshop, where we have the speaker, Dr. Rutu Parekh from DAICT, will make you learn about various basic building blocks of this system and how the functionality of each building block will take place. Okay. So with these words, I don't want to take much of your time. Straight away, we will start with the session of the ma'am. Okay. Thank you, all of you.
Thank you so much. Good afternoon to all of you here. I would just like to know that have you studied embedded IoT as a course? Raise your hand, just so that I know. EC students, you studied. How many? Only 3? 4. How about others? You are from computer science or?
EC only.
EC.
It's a subject of 6 and 7.
Oh, okay. So yet to be there. Okay, I see. No problem. Okay, so as you can understand, IoT, that is Internet of Things, right? Internet of Things. Internet, everybody knows. And how about things? So we can first, what is IOP if I say? Internet of People. Can you give an example of Internet of People, some application? Internet of People. It has come from that, okay? So first it was Internet, then Internet of People, then Internet of Things. So what is Internet of People you all have been using? Yeah, for example, WhatsApp. Right, so the people is communicating on the internet. Now it is things. So what is things? That's what we are going to find out, right? So as you can see, we'll have some basics, right? Because many of you are yet to study this. See, the goal here of mine is to drive you through the practical experience as a professor. I have been doing, I can say, if not 100, tens of such projects. And that too, if you go to the net, you will find a lot of websites, okay, YouTube, the starting point. Even I tell my students nothing wrong, rather than just, surfing through Facebook and YouTube, just see, when they come to me and they have to learn some basics, start with YouTube. Nothing wrong, because this is where it is entertaining and you gain the knowledge at the first step. So, yeah, I just missed what I was telling you. You have the phone here. Yeah, so the goal here is to drive you through the practical process of how to build the thing, okay, and where to look, what to do, and what the approach should be. And when you are doing, when you are learning the subject, right? Do you do the project? right? And it has to be compulsory. The project, it has to be compulsory. So you have to request your professor. I think it is very nice. So as you can see, by 2020, so we have already passed that, and the world population, that is the number of people in the world, and how many devices connected. Okay, we are soon going to see what are these devices and how do they connect. And this is just Internet of Things. So it was Internet of People, your mobile or your computer through which you could interact, and now it is Internet of Things where everything has been automated. Okay, factory, automobile is less of automobile, now more of electronics. Okay, so as this is just an evolutionary graph. Okay, and it started with mini computer, then personal computer, then as I can, let me have the pointer. Yeah. Okay, so this is a decade. Every decade, you can see how things have gone, this evolutionary process. And the beauty here of electronics, the way the revolution has taken place, right? The beauty is because of, can anybody say, electronic students? Why has electronics, yeah, the revolution that electronics as a technology has gone through is many, many fold compared to all other revolutions. Why? What is the base? This graph, because you can see every decade it is miniaturizing. There's a miniaturization, right? Why? I'll be asking you all basics only, but you should be aware of.
Nowadays, people want more handles of.
No, why this miniaturization? What is the technology that has enabled miniaturization? As you know, your mobile phone, every time you go and buy, right? Every year or two, it is lighter, the battery lasts longer with more functionality. Why? You know VLSI? You know the Mosfet transistor? What is happening to Mosfet? You know IC? So what does the IC contain? Integrated circuit contains what?
IC.
Integrated circuit. You all have said now. What does it contain? As you can see here, this always, the size is decreasing, the capacity is increasing, speed is increasing, less power, more speed, more bandwidth. Why? Who will tell me? Sorry, Mario. I touched by mistake, but here. See the MOSFET, you know the structure of MOSFET? Okay, Moore's law, have you heard of Moore's law? Okay, see Gordon Moore is more than half a century back, that is more than 50 years it is now. Okay, he had predicted that this MOSFET will become smaller and smaller. Okay, how much small? Half the size every 18 months. Okay, so that's the reason that your electronics is getting miniaturized. But now there is a problem. There is a red brick wall. We cannot miniaturize further. Okay, there is a saturation now. What is the reason? There are problems. There is a red brick wall. We are making it smaller and smaller, but now we cannot do it anymore. Why? Because there is a physical limit. Okay, and the physics that comes, there's a new physics that is appearing because of the small size. Okay, all it is becoming at an atomic scale. You can count in number of atoms now. The size is so small, in nanometer. And then the physics that is there is quantum mechanical effect, and that is completely out of world physics. The device don't work as they were designed when they were bigger. Okay, so that's the problem. And what is the future? What is the future of this? The future is nanoelectronics. Okay, I mean, you should be aware of as an engineer. So now, these are, as you can see, IoT is everywhere. Okay, IoT is everywhere in transportation, smart city, energy, whatever you name it, it is there. And it is there means it, the goal is to automate. Okay, we want to automate the system. Why you want to automate? It's just that we want to be, we want to have leisure in life. No. Why do we have to automate? Simpler. What do you mean by simpler? What are the advantages of automation? See, every technology is driven by demand. Okay, what is today's demand? What do we demand today? Pardon? Yeah. See, this mobile technology, right? Because of this mobile, everybody we now need mobile, and then we are asking for more. What is more? We want to control something remotely, data, right? The data, the processing power, the functionality it gives. So now there is now, a different field. Now data, initially when the technology started, the data could be handled, but now it is too much of data. The server has to handle, it has to be transmitted. Bandwidth is the problem, power consumption, more transmission, more power consumption, right? So many, it is all a trade-off. Okay, so the point here is, we can look it at the back, I think.
USB में लगा दो
આગળ કનેક્ટર લગાડ
कनेक्ट कर सकते कुछ नहीं जरूरत नहीं पड़े आवाज रहता
બસ શું કહે છે
प्रोजेक्ट
પ્રોજેક્ટમાં કનેક્ટ
USB
Laser निकलते pointer
हाँ
से
जी
at the bottom. Or this is like that.
this check
What it is, okay. Yeah. So now this is just to get you an estimate of how strong the future is, okay, of this IoT. This is for different continent, and this is Asia specific, and we are a small part of that Asia specific, okay. And as you can see, it is Asia, we are still lagging compared to USA and Europe. So you can understand the level of automation, right, in those countries. So this is just how it works. So the bigger idea, okay, bird eye view of how IoT works. Right, so at the center, it is now when you say Internet of Things, what is the basic goal? The goal is nothing but to control, some infrastructure or some application. Okay, you want to control. It can be smart city, automobile, not just one vehicle, couple of vehicles. So now you want to control, and that too remotely. Now there are different stages. Okay, now the first thing is you have to sense. So there are a lot of sensors, and when you talk of sensors, also in that basket there are n number of sensors. We will see. I'll show you. And then in that particular, if you talk of temperature sensor, also there are varieties. Okay, so whenever you are designing, you have to get into the depth. You have to do PhD almost. Okay, of what to use and how to design. We will see that. So the goal is that you have to sense at the first level, then you have to transmit that. Okay, and to sense that you need some intellectual power that is given by the microcontroller, microprocessor, or your SBC board, that what are in use today. We will see what are in much use and which has come out. I mean, most of the projects they use those boards. So that's what. And then you need wireless modules, okay, depending on the bandwidth, the data you want to transmit, the power, the cost, the distance. Okay, so many things are involved. And then you have to, now let's say it depends on the application. Now remember, everything is application driven. It's not that you will put AI also, you will put machine learning also, you will put cloud also. Whatever is needed you will put in the application, and then it has to be optimum, it has to be robust enough with all security features. Okay, so that is the goal. So here, as we can see, so this is the overall picture that. So the main thing is you'll start with this, the data. So the data is to be sensed, and then it is collected at the node, means at the place. Let's say if we talk of agriculture, right? Then the farm that is really, really big. If you go to North America or Europe, the farms are really big, of a size of a village, I can say. And when you are deploying sensors there, then corresponding to the set of sensors you will need microcontrollers. So they may be doing the processing, or we will see in detail, or the processing may be done at the cloud. Okay, so what is cloud and all? I'll just explain you. It is nothing but a server which is remotely located, and the data is stored there. Okay, so that is then data transmission. Data has to be sent, then it has to be visualized, means it should be accessible, and you have to analyze that. Okay, and then after analyzing, it has to be some predictions. Now we are doing all this to come to some prediction, and then based on those prediction you want to control. Okay, so this is just the overall picture of how the data is handled. And then the trend and the statistics that coming IoT. So now, as I talked with IoT, it is all about data. The sensor collects the data, it has to be transmitted, it has to be analyzed, processed, and then some actions has to be taken on that. Okay, so now this big data. So again, so you have to handle this all big data. The server should be capable of handling. There should be enough bandwidth, power. Okay, power is another constraint. So all these things, and then. So combining IoT, so big data and IoT, it goes together. Okay, you cannot neglect it, and analytics could deliver incremental. So revenue of how much? $14.4 trillion. Okay, this is for the next decade, and then 94% companies believe IoT will impact global market. So see, if so, every now it is like something very compulsory. Like everyone, we need to have a phone. Phone is not. It is needed for some emergency, right? We all. It is compulsory now that every human being on the planet will have at least one phone. So that is something like that. IoT, the company has to implement, right? Otherwise, they are lagging some way or other, for productivity, for making their admin very easy with dealing with the other companies and all. So industry-wide communication protocol are necessary to fulfill the. And then we will see how, because when these devices are communicating, there has to be a common language. Okay, that is what is protocol all about. So we will see that. So different aspects of this IoT, you can see how much business or the future in terms of revenue it is capable of handling. Okay, so this is just showing some data related to so how many 15 billion devices will be connected to the internet by 2020. We have already passed that, and these are some figures, benefits, the risk. Okay, the risk is security mainly, and we have to see that also at the end of the day. You cannot just deploy something. Who stands to benefit? That is at the end, our life is getting easier, right? And I mean, just this shows how things are interrelated. So So this is the same thing that there is a computation happening either in the cloud or at the node, where node is nothing but where it consists of a sensor, a microcontroller, which is in itself sensing and processing. So that is node. It can be cloud or it can be at the deployment at the place itself. Okay, and so this is where the so then the data can go to so this is the data the server, the cloud that we say. Okay, cloud is nothing but this big data storage. There are servers lying somewhere in the world. Okay, and then remotely the data has to be. So this is all two-way process where this server data will be connected to the remote application. It can be in your Android phone. It can be as a web application developed. Okay, and then through gateway. Now what is happening, this is the generation where your data is generated, your IoT devices, microcontroller sensors. Okay, and then see again it is on the application. This is the overall picture, not that every system needs all of this, not every system needs cloud. Okay, so I'll show you some research papers and examples there how to design and what to do. But the point is that if you want to remotely access this, okay, so you want to automate your farm and then remotely access it, then the data has to go through the gateway, right? And then some remote application will access that. So it depends on the application again. So these are the different stages of IoT architecture. So all this is the things we will see in detail, the controller board, the sensors and all, right? And then the actuators, transducers. Okay, so you should be very much aware of what is the difference between sensor, actuators and transducers. So they all make things, okay, with microcontroller board. Okay, so this is stage one. And then through internet gateway. So gateway is nothing but a piece of hardware, right, that will collect all the data from different nodes. Okay, and it is going to process it and it is going to integrate. And so this is where the gateway is, and that gateway will be connected to the cloud, okay, or to another server. And then where edge computing, now this is another emerging concept. Now see, another thing that you should be ready always is, and you should be habituated to reading, some good magazines. Do you ever read it? Because this technology is continuously evolving. Every day new comes. Okay, new things in terms of these things. Okay, here edge, now edge will be in practice after like 5-10 years from now. After 5 years, you can say it is at some places, okay, in some applications, but otherwise edge computing is not the trend now, but that is going to be near future. Okay, and this data center cloud storage, and then finally to the cloud, and then remotely accessible. Now this is where machine learning, AI, all these algorithms are involved. So because this all data is to process, and these are different stages of processing. And then there are challenges. So this big data, how to handle, as I said, the server should have that storage, that power, that bandwidth, right? And it should be speedy enough. Handling high data is not easy. Connectivity, business model, then this how to, because now when all these things are being transferred from one, when this transfer is happening, yeah, there are protocols that has to be understood. The language they speak has to be understood by each other. Okay, so they have to be in coordination with each other and awareness. Not that all organizations are aware of. That's why we are still, Asian countries. Okay, China has progressed much, but we are still lagging because not everybody is. You are studying, IoT embedded, right? But if somebody, a big businessman, also a millionaire, a crorepati, will not know what these things are and how to implement. And even if they know, they will not have human resource to do that. Okay, so that's what is the problem here right now. Now, what are the challenges when you develop a project? Okay, so it is not that things are easy going. And as I had, it was nice that in your wall you had written, you learn from mistakes. I don't remember exactly, but So this is same thing here. You will make mistakes, and that is the best learning. Okay. So your sir has that very well written. Although I'm not able to remember exactly. So now, see what are the challenges that when you start doing some project and if you want to work on. So the first thing, most of the, I mean, this is given some weightage, okay? And even if you develop a proof of concept, we say, okay, the first prototype is very initial thing, okay? And even if you develop, testing is almost never done. As a student or as a some project also, if it is for some competition, even if you are doing, testing is hardly done, and testing is from all over, okay, mechanical stress, whatever, different in different conditions, not just that you attend the functionality. Okay, functionality you may attend, but then in some conditions it will not work. So temperature, humidity, or whatever, so depending on the application. Then poor market research. Okay, now what happens as a student if you are asked to do a project on some good idea, right? You whatever comes to your mind, you will come and run and tell your professor, oh, this is very, I seems to be very interesting to me, and I want to work on this, right? But before doing that, as I said, research is at each and every step. Up to the last day, research is a continuous process. And before you start working, you have to make sure whether that idea is worth doing. Talk to your friends, see the internet. What are there any such products? Because things are there, then there's no sense. I mean, there are multiple same thing in the market also, but you have to ensure that when you are doing something, it has to be of that level. Okay. Then, so all this, I don't know whether the resolution is good or not, but these are a couple of things that as when you want to begin a project, you have to look into. Okay. So, uh, so I mean, I hope you can read this. The project out of focus, insufficient data available. So you have to look to the application scenario. What will be the data, and in, so all these aspects that were listed here. Now let us see the design methodology. How do you design? And we'll take some example. So you want to start with the project, and then what should be your steps, right? From the very beginning, how you will do. So the step one here is purpose and requirement specification. We will see into each. The first one. So the purpose and the requirement. So what is the purpose? I'll take an example and I'll explain you, but this is self-explanatory. The process specification. Process is exactly like how the data will move. Okay, what you want to control. And then domain model. So now domain means this is technical. Okay, so this is completely technical, that which domain means what are the kinds of hardware, software, the protocols, and all those things. Then information model specification, the specification of your hardware, software in detail, you will get in and look into. Okay, service specification, IoT level. So now it is Internet of Things. So wireless comes, gateways come, cloud, IoT platform is very important. Now in today's date, there are more than 600 IoT platforms. Now which one you will choose? You will go for Amazon or ThinkSpeak or Firebase, whatever. Okay. Functional view specification, the functionality, operational device and application development. So these are all the design methodology steps that are involved. And let us take just an example here for step one. Okay. So here the purpose is to build a home automation that allows controlling of light in a home remotely using a web application. So let's say you want to design a home automation where using a web application means using a website, an application which is on the net. Okay, you should be able to control the light remotely. That's the goal. So the behavior is, so now you will define, now this is the goal and how the system should behave in detail. Okay, so the home automation should have auto and manual mode. It should have both auto and manual. Auto means what it says is that when the light level in the room switches, so when the light level goes down, it should switch automatically, the light. Okay, when it becomes dark. Okay, and the manual mode, the system provides option for manually So manually you can go on and off, or remotely also, even if there is enough light, you can off it. Okay, so that is what it should, that should be the behavior. And what should be the system management required? The system should provide remote monitoring and control function. So you will need cloud or you will not need cloud. Now see, there are different things. Now when you doing this kind of application, the next question should be how far you want to control, from half a kilometer or from another floor, let's say, or you are sitting in USA and you want to control, right? Then completely the hardware changes, your requirement changes. Okay, and then data analysis, the system should perform local analysis of the data. So now where this analysis should happen, so this should happen locally where your room is, so where the hardware and everything, right, in that particular room. And deployment should be deployed locally on the device, but should be accessible. So that hardware has to be in the room but accessible locally, right? And then security. So now it should not be that anybody can come and operate, right? So some authentication has to be there who can control that on and off. Now process specification. So it is all about how the data you will be using, your data, how you will be controlling. So mode, auto, manual. Auto is the radar go jata hai, no on, and then manually you that switch also. And when you enter that web application, you should be able to on and off. Okay, irrespective of whether it is dark or. And now this is very important. As an engineer, this is where your role comes. Okay. Now let us try to understand. So domain model specification. Here you will define completely how your data is moving. Okay, what will be your hardware and what will be your software. Now hardware, what is there in the hardware? Who will tell me? Microcontroller, sensors, actuators, all these things are there. Now see, when you talk of a microcontroller, there are n number of boards available in today's date. Even if you talk of Raspberry Pi also, there are many versions. Okay, so it's not that you will use the latest one. Latest one is very good, or whatever you need you will use now. If you have to just talk, you will not need so big a phone, right? Kuch chota sa bhi chalega if that is your requirement. Because unnecessary, why we will not use? Because it demands cost, okay, power, bandwidth, everything is involved. So exactly looking to your application only you will be choosing it, right? And then actuators, relay, here it will be a relay that will be operating this and to sense the light, LDR with sensor. And then if you go for, let's say, as I said, temperature sensor also, you will have couple of temperature sensors. You have to select from that. So then this is the hardware part. Okay, then comes the software part. So resources, so network resource or on device resources, all these things, the software that you will be using. So if you are using Raspberry Pi Zero, let's say, for such an application, right? Or whatever the Pi, then you will have to have the OS about that. Okay, if you are doing wireless communication, then all those wireless protocols sits before about that, and so on. And then there can be the gateways that will connect to the cloud. And then, as I said, if you want to access from North America or any part of the world, right? So your physical entity, your room will be connected to that virtual entity. Okay, so every this room or the other appliance in that room, for that you will create a virtual entity, right? Because this is a hardware software that is controlling a piece of hardware. And then so this is your hardware part, this is your software part, and it will and see, here is the user. Okay, this is the app, and this is the manual, this user. Then this is the app for remote control, and this is the service that you will be using, and this can be a cloud-based IoT platform. Okay, so in all, you have to define your hardware, software, the cloud. And as I said, if you are working just from the above floor, then will you need a cloud IoT platform? No. Then how will you do? Giving the wireless module that has enough range. Okay. So, so now we will talk of this module. Okay. So now, so as I said here, as I said, transducer, sensors, actuators. Okay. So what are this? What is a transducer? You can see this. You all know. So this you have understood what is written. Can you give me an example of a transducer? Very good. Huh? Pardon? Very good. Microphone, speaker, right from this diagram you can understand. So that are transducers, okay? Now sensor. This pic I have kept because the automobile is the best example. There are not tens, hundreds of sensors in today's car, okay? And there is a computer also inside. And we say that as OBD, on-board diagnostic. So each and every part of your car is tested. Okay, and if something goes wrong, we are not using that. But if you go to North America and if something goes wrong, they will have that software installed. I mean, they will to the software. They will look. They will connect. There is a port here in the car, just below your steering wheel. Okay, OBD port we say, and that is compulsory now from last 4 or 5 years for every car that is being bought, where that is being manufactured. Okay, and that OBD. So you will connect through OBD scanner to your laptop, the software, okay, and then it will transmit that code to your laptop, and it will say that which part of your car has gone faulty. So you can understand the level of automation, and this is all IoT only, okay. So sensors everybody knows, and actuator. What is actuator? So it is a mover. Actuator, other name you can say mover. Okay. So based on what is sensed, it will take some action. Okay. Can you give an example? Hmm? Yeah, motor. Very good. And you know this airbag. Yeah, the accelerometer is the sensor, and then the airbag will come out. So some action is taken there. So now the transducer is divided into two parts: sensing element, okay, and then transduction element. So just to make you aware of these things, they are all involved when you design the system. You need it, okay. And then, as I said, there are various categories. Okay. So on the basis of the principle used, they can be capacitive, inductive, resistive. So now see very important thing. So classification of transducer, they can be analog, digital, electrical. So these are all different kinds of. As I talk to you, see when you talk of a sensor or a transducer, right? At the end of the day, some when you talk of electronics, right? What is the parameter? So if you say temperature sensor, what you see is the temperature in analog form or digital form. Okay, depends on how the sensor is working. But inside the sensor, right, some electronics is happening, and that is in terms of R, L, or C. Either resistance is changing, either capacitance or inductance. And then when you give some voltage, as per the change, the current will flow, and that is sensed, that is calibrated, and what you see is the parameter that you want to sense. Okay. So because of pressure, force, R changes, resistance changes. Okay. And our temperature, that is how the temperature sensor works. The temperature is changing because of the gas. Okay, it's not tough if you understand. And the main figure is so here you have two kinds of sensor, digital and analog. Okay, and now when you are building your system, right? So the first stage is sensor. The sensor input goes to the microcontroller, but in between that, there are a lot of other stages. Okay, the sensor, whatever it is sensing, it is really weak. So first of all, amplifier you will need. Okay, if it is if it is the digital output, okay, you will get exactly. I mean, you can store it, process it, transmit it, and then analog. If it is analog, you have to convert into digital. Okay, so then you will need A to D converter. Now, which A to D to use also? So, okay, so these are all. Now, see what is happening. In short, this is the, sensor. There are the two categories: digital and analog. Now, what to do next? Before I go to the other this part, these are some of the sensors. Many are there here. So acoustic and noise, temperature, humidity, pressure, absometer, gyroscope. It will show you the angle. Okay, flow and gas sensor, infrared, optical, all this. Air quality, water quality, right? There are pH. All these sensors are there, and smoke sensor, alcohol sensor. So this is just showing you that, and then using these sensors you can build any of your application. So for example, let's say that if you want to find out, you want to build an application where you want to find out whether the soldier, okay, at the military at the border is dead or alive, then we will equip the soldier with some electronics which has a sensor controller. Right, so which sensor do you think can work here to find out whether soldier is dead or alive? Somebody is dead or alive, especially military for the military personal safety. Which sensor sensor? Yeah, reason. How?
जो आदमी जिंदा है उसका कुछ टेम्परेचर अलग होगा, अगर डेड है तो उसका टेम्परेचर डिफरेंट होगा, तो इसके बेसिस पर हम कुछ अंदाज लगा सकते हैं.
That the body may get cold after some time, right? Any other better answer, huh? The accelerometer and everything is there. I'm not talking of that accelerometer sensor. See this accelerometer also, right? Because if somebody is dead, is not moving, you can know from this. So you all know analog signal, digital signal, right? And that analog has to be converted into digital. So analog sensor, okay? So this analog sensor usually has 2 to 3 wires, okay? And then, so let's say it can be pressure, temperature, flow, level, right? And then the output will be, it will be whatever the parameter that goes, and then the voltage. So these are the input, and the output will be, it will have 2 to 3 wires, and it will give you this voltage as an output, okay, some current, and then resistance. So let's say here 3-wire variant has 2 wires for power and third as an output, okay. So let's say for this sensor here, what you will have is this is your voltage, this is ground, and then this is the analog of the sensor, the output of the sensor, which will go as an input to your controller. Okay, so it has three, and if it has two, then this two, right? They are by resistive divider. They is given to resistor divider circuit. They form a resistor divider circuit, and it is given to the load. And then digital sensors, it will give you the output, right? But then the accuracy comes here, right? The number of bits and the accuracy. Okay, now very important thing. The three most common. So now, when you are using digital sensors, there are protocols. Protocol means this is the language that they speak when they are sending the data, the sensor. Okay, the protocols are I2C that you must have heard of, SPI, serial peripheral interface, or one wire. There are several others, but these are most commonly used: I2C, SPI, or one wire. So this is the protocol, and that's how they have to be connected. Always needs to find, and then for digital sensors, you have to find a library. Okay, and then so for example, Raspberry Pi. Okay, it is an open source platform. It uses Linux operating system. Okay, and then you can download the APIs from, and then lot of peripherals. You will get the code snippets and everything. I mean, I can show you if, but you can go to raspberrypi.com, right? And then you can find out more. And I mean, a lot of resources for such. And then here, again, very important thing that I would like to share with you is. Here, what happens? Let me go to. Yeah. So see, for digital sensors, the I2C protocol, how it works. So I'll come to that point that I want to share. Very important. So classification of the, still we are with the digital sensors only. So here the microcontroller, ADC, DAC, right? So this is the master. You have the slave. And this is the protocol where you have, these are the three wires, VDD, SDA, SCL. The SDA is serial data line, okay, which has your data. This is having the data, this is giving the power, and this is for clock, synchronizing. And this processor has to be synchronized with them. And they are master and slave, they all have an address. Okay, so one by one, the transmission not simultaneously. One by one, it will be happening. This guy will be controlling, and it will be synchronized with this clock. So this is how your digital sensors are integrated. Now for your analog, so this is what the two, yeah. So how it, the communication between so many devices and just two wires. So how do, so every device has an address, unique ID. Okay, and this is the, as I explained you, the same thing. So in short, there are protocols that we have to look into, I2C, SPI, whatsoever. Now see, this is very important, digital to analog DAC, and then ADC, you will need both. Okay, so analog to digital. So if your sensor is analog, you have to convert it into digital form. Now to convert into digital form, right? So these are, this is D to A, this is D to A to D. Okay, so analog to digital. So you will give an analog input. You will, this is 3-bit output. Okay, so where operational amplifier and this guys, this they make A to D. Okay, and that can be given as an input to the controller, because the controller understands 0 and 1 only. Now, very important thing. Now, say for example, if you are using Arduino, you have heard of Arduino board. I'll come to that also. Yeah, so if you have used Arduino, okay, Arduino has A to D, but this Raspberry Pi doesn't have. Okay, so now how will Raspberry Pi process? So what the Raspberry Pi will do? So Raspberry Pi uses Python coding. Okay, and in that, in the library that using pulse width modulation, using PWM. So it is the code. The code will convert the analog to digital. Okay, and that will be for processing. So it is in form of data, right? But let's say that you have to give this to some output as an hardware, then you have to have this circuit there. Okay, but otherwise, if you are using Pi, the Python code can do this one. Okay, and this is very much used whenever you develop something, you'll be using Pi. And if you have, because when you have a sensor, for example temperature, which is this, then you will by coding you can convert using PWM, you can convert into a digital form. So this is A to D, and then these are D to A, digital to analog converter. There are also types. So for everything there are a couple of possibly options you have. And this is weighted resistor, so you can see that this is a 4-bit yeah, the 4-bit digital input and analog output, and this R2 R4 are there in that order. Again, operational amplifier. So if you have to build this operational amplifier ICs, you will get, okay, and you can build this, or you have to find out whether it is a part of your microcontroller or not. But wherever you, because in applications, that's what is your application and what is the need, accordingly you will have to even build it. So this is R2R ladder. So you can see this R and 2 are only two things are used, and it will convert your again D to A. Okay, operational amplifiers are used for building any damn analog circuit. So now, as I said, next thing you will need is wireless modules, and there are also a couple of options. All this you have heard of RF, Bluetooth, Wi-Fi, Zigbee, LoRa. Now they all have see the cost, the distance, the bandwidth, the power. Okay, everything. So depending on the distance, you will choose them. Okay. For example, this LoRa is again something great. That this is end-to-end communication, wireless, where it has, this is long range. From the name you can understand, long range, but the bandwidth is low. You cannot transmit video and audio. Okay, but critical information you can transmit using LoRa. And if you go and see YouTube, in Europe they have done up to 100 kilometers of distance. They could send the information. And what is this? It will not need any internet, no internet. Okay, no 4G, 5G, nothing. No internet, nothing. It is modules at the transmitter, at the receiver, and long distance it can go. Again, you can also transmit video, audio. It's not that you cannot, but it will not go that long distance. Okay, and so it is a trade-off. Okay, power, bandwidth, all these things. I was talking to you that IoT development boards, by time many development boards have come, and if whatever the streams here are for Raspberry Pi, also there are different versions of Raspberry Pi. Depending on your use, you have to select. So this is Pi, then this is Omega, Particle Python, and all this list that you can see. This is Arduino. So these two have emerged, and ESP32 is another one which has this ESP32, and this is for the camera here. This is ESP32, and it will have a camera also inbuilt into that, plugged into that, and it is really low cost. Okay, so depending on the use, you have to select it. And then let's say that just this example, I have kept it here for you. That this Arduino, now sometimes most of the time, because these two are mainly used, Arduino and Pi. So now the first question is which one to use, Arduino or Pi? Okay, so again it is your application. So see, now this Pi is SBC. SBC means single board computer. It's a mini computer only. Okay, your Pi. It has an operating system. Everything is open source. So you don't have to spend except for the hardware. So, and then see, this is for the Pi. It will support audio and GUI. You will have an interface, right? GUI, that is graphical user interface, and the way you work with Windows and all, you can do your work. Okay, and then wide range of operating software, using all APIs software, you will get it free, and uses had for extending. Now this Pi only, they have come up with another module that will fit above Pi, and it will have a lot of sensors and a display. So it will show you there only everything. You don't have to have wires and connections and everything getting messed up. Okay. And then best at the logical processing of data and communicating with other systems. And then when to use Arduino, they will not support audio and GUI. So if your application demands this audio GUI, you will have to go for this. Don't think of this. Right? And then so all this. So in short, it is the decision as a user, as a project leader, you have to make it. Now, my inputs that I want to share before I drive you through some research papers, okay, of the projects that we have done with my students, I have done. So here for students, the development steps. So see, today the technology is available at our doorstep. If you order, it will come to your table now. It is there. Okay, open source tools are there. You don't have to pay for the software, nothing. Now, the first thing is the idea and its practical use. Now, see, the technology is there, but I was talking to you about the soldier, the military soldier. Okay. Now, they work in troop. And then if somebody is dead or in emergency, even the control room doesn't come to know. Now, that is something that we should really do for our soldiers, right? As a student, so if you have to work on something, it should be something which is helpful to the society, right? Something which has and practical use you have to do. And research on the topic as we want to day last. Okay, so first you will start with YouTube. It's not about time pass. YouTube is very informative. You start with YouTube on this, and then Google, and then research articles, research paper you have to read. How to read, and all this is also an art. It's not that one paper you will go on reading for a couple of days or one day. No. How much in life also, how much to कहाँ छोड़ना है, कहाँ पकड़ना है. We have all this know-how. Same thing here also. How much to read, where to catch, how to write, how much to write, what to leave. Right? This is an art. So that is a different thing. But you are all intelligent enough. By time you will develop it. Okay, and then proper hardware selection. So you have to select which exactly the controller board. Similarly, sensors, IoT platform, which hardware, software tools. So if it is Raspberry Pi, then it's a hell lot of big resources there. Okay, so you should make use of this. And then see, now your application may demand lot of functionalities. Okay, that you have to do this 10 things. Then you do one by one. Not that everything you will do, because first you will see the functionality. You get the one, then you go step by step and you go on adding the functionality. Okay, and then addition of then the wireless module, network protocol, and then security. But main thing above all this that I must stress is work in group. Okay, work in group, and some may be good at coding, some may be good at hardware, some may be good at research. And it is always motivating. If you are working alone, definitely you will leave the project in between. And then always work with students, your friends. Work with your friends who are sincere and serious. If it comes all on you, then please don't do, because there is no shortcut here. It's all your hard work only. Okay, so so now when you want to go to the cloud, you want to have your data on the cloud, you want it to be processed, okay, and then remotely accessed through Android application. So you have to develop an Android application also, right? So for that, Android Studio. But see, now we as an EC engineer, we may not be that okay. Android Studio learning is altogether a different game. So there are, see, for everything there are facilities. You can use MIT app. It's a website. You can drop. Okay, it's a GUI. You can very easily develop an Android app. Okay, there's an MIT app. You just write it down and you can go and see. So for any small little thing, let's say you are sensing a temperature for learning, you want to send it to the cloud. It can be Firebase or ThinkSpeak something, and you can easily develop an Android app. Okay, using this Raspberry Pi Node.js, you can make a web page also and see all those readings and all. So you explore, and that's how. Yeah. So while you select an IoT platform, also you have to look into the vendor parent company, the reliability, the scalability. Tomorrow, if you are adding more and more of the parameters or the users, it should be scalable, right? And then the protocol support, okay, customer support, user friendliness, all of these things you have to look when you are selecting. And there are more than 600 IoT platform in today's date. So that is very important, which one to select. Now see, those who are looking for career, now see, this is completely interdisciplinary. And EC students are the best fit. Okay. And as I said, the technology is evolving every day. And then you have to use that new technology, latest thing only. For that, you have to be updated. You have to use the magazine, you have to read, you have to be in touch with all the recent updates, journals, magazines, internet resources, whatever you think you are comfortable. Okay, so see, this is just to show you the carrier I'm talking of. But IoT consists of embedded. Embedded doesn't consist of IoT. Okay, so and these are the mix of computer science, electrical, and if you are working for an automotive for an automobile application, then you need to have the knowledge of automobile also. Okay, so all of this knowledge is very essential. Otherwise, you cannot develop anything. And then here is a technical skills. You need to know computer architecture very well. So before you are this SBC board that I was talking to you, each and every board you have to, if you are selecting a particular board, if you are selecting particular board, you should know each and every GPIO pins, the interfacing here, right? HDMI, whatever these interfacing are. If you have to connect a camera, a microphone, right, couple of sensors, you should be able to figure it out. So that hardware architecture part is very important. Yeah. So then you have to understand the peripherals. Yeah, very important. You have to see the manual. If you are using a sensor or whatever the hardware component, always see the manual, the data sheet. Then the protocol networking and how the data is moving, the programming language structure, validation and verification, PCB, everything. At the end, you will have to develop a PCB for that. Then later, if you are planning for some startup or something, then you will have the first prototype and then so on, and then the security, the quality assurance, compliance, all the certificates you will have to get. It's doing creation, about battery management. Last but not the least, right? That is important. And not technical skills, all this, including creativity. Okay, so and today in today's time, it's all about startup. Okay, and lot of fundings, SSIP funding, if you know, for students, the government gives very easily. And then for if the idea is good, you want to have, if you have a first prototype, you can approach and you can have your startup, you can get a fund of around 20 lakhs. You don't have to return that, all these funds. Let me show you some. No, not done. Wait. It is already, but let me drive you through some papers. See, I am giving you these examples of few papers, just motivating and to show you a way. Okay, that our BTech students, my BTech students. Now, see this paper now, and if you can see this, here the idea was, first is the idea, and as I said, it should have some practical, right, implications. So for those who are impaired, no, deaf and dumb to say, right? They talk in language, but everybody doesn't understand, right? So if I am deaf and dumb and I'm doing some, you will not understand. So the student developed an app in the phone. So using that glove, he will wear, and whatever the actions are, the text will be written on the phone, right? So just to show you, and this all prototypes and everything was developed. So see, this is the small, all this with Arduino only he did it, okay, Arduino, Nano, and this sensors, and then the smartphone through Bluetooth, right? So this is just, this is the phone. And these are some signs, okay? And then the data processing, because the signals, that accelerometer was used here. And then on this, they depending on that action, how are you, okay, and it will print in English. I think this was this Chinese and this German, 3 pages it could show, for example, okay. So the point is, and if for such a project you can get an SIP fund, right? And then later on, if you have really, this was we developed even UAV, that is drone. Now drone, you will not believe. I am giving you an example. This is again motivating for you. That it's the drone now you get ready-made, okay, and you have to install some software and it will fly. But the goal was not that. The goal was to make from scratch the drone. And as you can know, it has to get elevated and then it has to fly without being shaken. I mean, even if there is little bit of air, right, with force, it will tumble, it will come down. That stability and everything. So the main part of this UAV is the controller. It's a PID controller, which will make it stable, even if it is little bit tilted or whatever. And it was started as an MTech project. This is tracking UAV. So then you want to send the UAV and it should reach that destination through the shortest route. So this was the paper regarding that. And as just to show you, so do you do any research project? Your goal should be to write down the paper also then. Okay. See, now this is the block diagram where you will see this cloud also there, then this laptop where you can see this interface, and in the Google map where the drone has reached. Okay. And it can be tracking the drone also. It can track any vehicle also. Tracking can be of anything. It will take the location, GPS, and then through this cloud is there, right? So this was, everything was involved in this project. And then whatever the technicalities are, and you will be able to see the path of the drone, the path it has taken. Okay, so with all GUI, everything cloud there, API, this if there is an Android app, whatever has to be done. See, this was again for soldier health monitoring. So this was the block diagram. Let me make it bigger. Yeah, so this is this is little bit blurred, but there are a couple of these GPS, all these sensors are there. This is the controller, and then see the LoRa module we have used. Okay, so depending on the application, because there is no tower, there is no 4G, there is no 5G. You understand? And then I can show you. See now with this pi, all these peripherals with the pi. Okay, all the ports were used. The goal was to develop this flexible belt, which will have all this electronics and using pi. So this was the algorithm, right? Because you need see the main thing of this is the algorithm, because that's what your logic is all about. And then this processing of the data, you have to filter it out, you have to filter and A to D, D to A, whatever, right? And then see on this GUI, this was on the using Python or using Python only. This GUI was developed on the PC of the control room, where when there is something emergency there, it will say emergency depending on that algorithm. Okay, and if you click here, it will show the location of that soldier. So all this thing, when you do it, you have to do it fully, and it has to be in group. Somebody is doing something, then you integrate everything. And this has worked. Every time we do something, we are always successful. That's why I'm sharing here. See, again, another this project was because that time, because of this rain and all, this we find out. So using techno, this is not something that you will go and use it directly, and but the first prototype that was developed, and the students worked, and so it is all, as you can see, just the block diagram. Then we made the bridge also. Was a prototype using this all this plates all. Then we made, and with this data, and then data. Okay, then did some because this is mechanical also. So it is all interdisciplinary. What I want to tell you is, right, and then to find out if there's a gap or whatever. So this all by students like you. So do the students write down paper here? So see, this is another. This sensor had come up at that time only. So this was to find out that in the military. So if it's the India-Pakistan border, and you want to find out if there is somebody on the other side of this wall, right? Then this MAM sensor was used, and uh, to see all this block diagram and how the data will move, and about the sensor, you have to understand the sensor, the schematic of that. You take the data, you process it, and then you from that you infer something. Okay, so and it will send an SMS to the mobile station, and with the Google Map and all, it will detect if there is somebody on the other side of the wall, or beneath the ground or whatever it will sense. There are the uh, just let me show you one or two more. Okay. again, this was another interesting paper. What I want to tell you in this is just 1 minute. Just what I want to hear is that in this paper, the goal was to detect an accident, okay, and accident testing, and then to send the information and also on for the EMS emergency for the hospital in the vicinity, we get the location and everything. But so that was one of the project that we did fully. We developed the web application, Android, and then through the phone also they'll get the SMS. Everything was done with the link where the accident has happened and all. But this was again just in support of that. Another way of detecting an accident is through machine learning. Okay, and because as I said, it has to be 100% accurate. The algorithm has to be 100% accurate. Now this machine learning, so this was not an efficient system of figuring out whether an accident has happened or not. Okay, the accuracy that was around 85%, and so using images and machine learning to find out. So, but this is not an efficient thing, but still, just to make a point, and we did thorough research and we implemented it, and then we published a paper also. So it's not that you learn it, it may not be advisable, but still the result is important. Okay, so I think it was a long project, the last one that I shared with you. The point here is the idea is very important. Okay, so you should work on something that is useful. See that PUC everybody knows, right? We have also done PUC. That OBD I was talking now of the vehicle. So that PUC, you know that how much prone it is to malpractice. We also get now. You pay money, they will give you. Even if it is polluting, you will get the certificate. Now this is completely digital. And this is using on OBD, onboard diagnostic. Your vehicle has a computer, as I was talking to you, it has sensor, it will give a code. So this was to test the pollution. That vehicle will come and you will plug in that scanner that is below your steering wheel, right? And you will get information about the exhaust that it will give. You have to keep the car on, okay, and it will not take more than 2 to 3 minutes, and then it is completely digital data. It will send an email or in the RTO wherever it is, and this is something where this has been applied or is being in use in European countries, Netherlands, and in one state of USA also. But in India, it's yet to come. But this is very important. So, but the student worked on this, and even we got SSIP fund for this. And the goal was to have it as a pilot project for Gandhinagar or Ahmedabad, where this kind of testing can be done. You understand? So, in short, it is all interdisciplinary. You need to have a knowledge of what you want to do, plus all this. Okay, so with that, I think I'll end my lecture here. And if you have any queries, see, I tell my students, if you don't know answer, it is okay, but you should ask queries, okay? Or you should ask questions. So questions are welcome.
Any questions?
See, if you don't ask questions, we cannot expect answer from you.
Yes, any questions from participants?
So who has written paper or have started or planning?
This all, madam.
Okay, very
Final year
good.
students.
So what is the topic of your work?
detection of infiltration and all.
That UAV you got it, bought it. Okay. So what will be your research in that?
Like I'm planning to make it capable enough to detect any kind of infiltration and also at the same time destroy it in case it causes the disease.
The UAV will get destroyed.
We will destroy the infiltrated infiltration of sea in the waters.
It's a nice project for military application. So if you have a prototype developed, you can go for SSIP fund. And for military, it's a high priority. So how many of you are working?
Me and
Okay, and what are you doing then? No, but see, home automation is saturated. Okay, so not to waste time. But this project is good. You join them because if you have like 2 to 3 things to do, you can have 1 or 2 in doing each of the thing, and that will be more motivating. At the end, you will have something working. Home automation is saturated. For learning, you can do. If you want to write a paper or something, go for fund. And see, this funding, it is like, if it clicks, means the point is, if you work on such a good idea and if it gets clicked, you are again another Dhirubhai or Karsanbhai. Okay. And then money makes money. From one product, you can have multiple. But only an EC engineer or an ICT can do. No, I mean it. वो पीछे पड़ जाना पड़ता है. As a team, you can do. And the world is the market. The only thing we were lagging is foundry. We didn't have chip production. But now in future, we will have that also. So, I mean, in India, it's the right time. Make in India. Okay. Anybody, anything? No? Okay, then I think I should end. Thank you.